Assalamualaikum and greetings to Sir Azri. I am Shafiq Najmi from Group 5, and today we will present our second group assignment titled Engineering Finance Analysis for Innotech Manufacturing Limited. This presentation will demonstrate how we translate complex technical design requirements directly into clear financial parameters, ensuring our engineering capacity grows hand in hand with our structural profitability. Let's begin with the introduction. Our analysis centers on Innotech Manufacturing Limited, a medium-sized engineering firm operating in a highly specialized technical niche, which is producing high-efficiency HVAC units tailored for hospitals and green buildings. Because healthcare facilities and sustainable buildings demand precise, rigorous engineering standards, the standard one-size-fits-all financial approach will not work. The primary objective of this report is to bridge the gap between engineering and finance. We aim to align our structural profitability with our capacity growth. To do this, our scope spans across several critical domains, ranging from cost classification and job costing techniques, which I will cover next, all the way to budgeting, project evaluation, and decision-making tools handled by the rest of the team. Moving into Chapter 2, we establish our financial groundwork by classifying our cost based on two pillars, cost behavior and cost traceability. First, cost behavior looks at how expenses respond when production volumes change. We categorize this into fixed costs, which stay flat regardless of output, variable costs, which scale dynamically up or down with our factory activity, and mixed costs, which carry a flat capacity fee plus a usage-driven component. Second, cost traceability measures how easily we can track a cost down to an individual product. Direct costs are easily traced to a specific unit, whereas indirect costs or overheads support the entire infrastructure and cannot be isolated to a single output unit. Based on the table for the Innotech HVAC project, materials like steel casing and touch labor assembly hours are classified as variable and direct because they scale in a straight line with the number of units built. Factory rent represents a fixed indirect cost because it has a flat monthly rate regardless of our factory throughput. Equipment maintenance functions as an indirect mixed cost due to its combination of a fixed structural retainer and variable wear and tear fees. Meanwhile, testing lab electricity is variable but indirect, driven by final quality assurance runtimes. Crucially, for long-term engineering decisions, we distinguish between sunk costs, past expenses like previous research that are ignored to prevent the sunk cost fallacy, and relevant costs, which are the expected future expenses that will actively change depending on the strategic pathway we choose. This brings us to Chapter 3, Costing Technique. The costing technique chosen is job costing and not process or activity-based costing. Why? Because hospitals and green buildings have unique structural, environmental, and strict regulatory demands. We are not mass-producing identical consumer goods, but instead, each HVAC bill is treated as a distinct engineering project with its own custom sensor layout, tailored material configurations, and specialized ducting. Utilizing job order costing gives our management team precise control over material and labor tracking, which is essential for accurate cost containment during our upcoming market expansion. This table shows the baseline calculation for a single high-efficiency HVAC unit. Our direct materials, comprising of the steel casing, internal piping, and specialized sensors, totals to 1,100 ringgit based on exact unit allocation. Our direct labor accounts for 20 hours of hands-on assembly and testing time, calculated at an engineering wage of 25 ringgit per hour, which equals to 500 ringgit. Finally, we apply our factory overhead at a predetermined rate of 15 ringgit per direct labor hour, contributing 300 ringgit to cover indirect expenses like rents and utilities. Combining these three elements give us a total job cost of 1,900 ringgit per HVAC unit. This transparent cost block is exactly what allows us to confidently establish pricing, manage margins, and smoothly transition into budgeting. That is all from me. Thank you.
Moving on to section 4, budgeting and forecasting. Let's look at the operational roadmap for the first quarter of Innotech's expansion plan. To ensure the performance measurement framework is grounded in reality, we have established 5 core financial assumptions. The first one is our unit selling price is set at 2,500 ringgit based on the standard healthcare back-to-back contracts. And second one, our variable cost per unit is modeled at 1,600 ringgit, which includes all direct engineering materials, touch labor, and variable manufacturing utilities. Our baseline sales volume launched at 180 units in the first month instead of arbitrary flat grow rate. We are scaling production strategically to 200 units in month 2 and 220 units in month 3 as our new capacity layout stabilizes. Finally, our structural fixed costs are capped at 450,000 for the total quarter, distributed linearly at 150,000 per month. So, at the budget structure, we can see how this engineering economics translate directly to our bottom line. In the first month, a volume of 180 units generates 450,000 ringgit in revenue, leaving us a slim net profit of 12,000 ringgit after covering fixed overhead. However, as production scales up to 220 units by month 3, our revenue reaches 550,000 and our monthly net profit quadruples to 48,000. Cumulatively, the expansion is highly viable, yielding a total first quarter revenue of 1.5 million and a healthy net profit of 90,000 ringgit. Moving on to section 5, break-even and profit planning. In section 5, we cover our cost volume profit analysis or CVP analysis. So by subtracting our variable costs from our unit selling price, we find that our CM, contribution margin per unit, is 900 ringgit. This means every single unit sold leaves us 900 ringgit to chip away at our fixed overhead. When we divide our quarterly structural fixed cost of 450,000 ringgit by this 900 ringgit margin, it reveals our critical zero profit threshold. Inotech must sell exactly 500 units or generate 1.25 million in revenue to break even over the quarter. So in the CVP plot at the right side, to the left of the 500 unit intersection, we can see the shaded loss zone where our revenue is simply not enough to cover the factory's fixed structural costs. However, right at the 500 unit crossover marker, the company achieved operational equilibrium. Beyond this point, the shaded green profit zone widens rapidly because our fixed overhead remains flat at 450,000 ringgit every unit. We produce above 500 unit passes its entire 900 ringgit contribution margin straight into the company's earnings. So linking this back to our operational budget, our target of 600 units lays us safely inside the profit zone. This gives management a margin of safety, MOS, exactly 100 units, meaning our sales can underperform by 16.67% before this expansion faces any actual risk of financial loss. So looking further down the line towards 1,000 units, the exponential profit spread proves that this capital investment scales beautifully and presents an incredibly low risk profile for the company. I think that is all from me. Thank you.
Alright, so next I will explain about the capital investment in the project evaluation using the NPV analysis and the IRR technique. So Inotech Manufacturing plans to invest in a robotic welding system that costs 300,000 ringgit. So the equipment is expected to generate annual savings of 90,000 ringgit over a period of 5 years. So based on the NPV analysis, the project produced a positive NPV of 41,100 ringgit, indicates that the investment creates additional values for the company itself. Furthermore, the calculated IRR analysis is approximately 15.3%, which exceeds the required discount rates of 10%. So therefore, the investment should be accepted as it improves both operational efficiency and long-term profitability for the Inotech Manufacturing Company. Next, moving on to inventory and cost control. So Inotech maintains 4 main inventory categories, which are raw materials, work in process, finished goods, and MRO supplies. So to improve the inventory management, 2 control methods are proposed. The first is the just-in-time inventory system, which makes sure that the materials arrive only when required for productions, which reducing storage costs and work in progress inventory. So the second implementation is of barcode or RFID tracking systems to provide a real-time inventory monitoring and improve the stock accuracies. So combine this together, these 2 methods help to reduce the operational cost, improve the production efficiency, and support the company expansion strategy itself. That's all from me. Thank you.
Assalamualaikum, my name is Muhammad Hazik Nazmi and I will present my slide about performance measurement and KPI and project cost management for Inotech Manufacturing. Performance measurement is important because it helps management evaluate whether the company operation are meeting their objective efficiently and profitably. To support the HVAC expansion project, several engineering-related key performance indicators or KPI are proposed. The first KPI is cost per unit with a target of less than Rm 1,900 ringgit per HVAC unit. This KPI measures manufacturing cost efficiency and helps management monitor production expenses. The second KPI is machine downtime with a target of less than 5%. reducing downtime, increase equipment availability, and improve production capacity. The third KPI is defect rate, with a target below 2%. A lower defect rate reduces material wastage, rework costs, and warranty claims while improving product quality. The fourth KPI is on-time delivery rate, with a target above 95%. This KPI reflects the company's ability to meet customer requirements and maintain customer satisfaction. The final KPI is overall equipment effectiveness, or OEE, with a target above 95%. Above 85%. OEE combines equipment availability, performance, and quality into a single indicator of manufacturing productivity. These KPI are directly related to financial performance and return on investment, or ROI. For example, lower production costs and fewer defects increase profit margins, while reduced downtime and higher equipment efficiency improve production output and revenue generation. Therefore, KPI monitoring enables management to identify operational problems early and take corrective action to improve profitability. For the next section, discuss project cost management during expansion of Inotech manufacturing. To ensure the project remains within budget, the recommended monitoring technique is Earned Value Management, or EVM. EVM integrates project cost, schedule, and scope into a single performance measurement system. There are three key components of EVM: planned value, which is the budget cost of scheduled work; earned value, which is the budget value of completed work; actual cost, which is the actual amount spent on the project. By comparing these values, management can quickly identify cost overruns and schedule delays before they become major issues. In addition, budget versus actual cost analysis should be performed monthly. This method compares planned expenditures with actual project spending and helps identify cost variance. The graph shown in the report illustrates this comparison and demonstrates how management can monitor project financial performance throughout the expansion process. Several cost tracking tools are also recommended, including an EVM dashboard, variance analysis, budget versus actual reports, KPI dashboard, and enterprise resource planning, or ERP system. These tools provide accurate and timely information that support better financial control and resource allocation. By implementing this cost management technique, Inotech manufacturing can maintain budget discipline, improve project performance, and support long-term success of its expansion strategy. Thank you. Let's conclude my presentation.
Assalamualaikum and hi, my name is Muhammad Izan bin Ismail. For my part, I will present about decision-making tools. For our expansion, Inotech had to make a big decision. Do we make our smart control panel ourselves, or we need to buy them from outside supplier? First, we look at the pros and cons. Buying from the supplier is nice because we don't need to spend money on new machine. But our HVAC unit are from hospital. We need a perfect quality. If we buy from someone else, we lose control over that quality. To be sure, we did the maths using expected monetary value calculation, EMV. This result is clear. Making the panel ourselves give us a return of 170,000, and buying them only give us 160,000 only. So our final decision is to keep production in-house. It gives us a better quality and more profit. As a conclusion, overall, Inotech is very ready for this expansion. Our maths show that we only need to sell 500 units to break even. This is very safe target. Also, buying the robotic welding machine is a great investment. It gives us a 50.3% return, which is higher than our company target of 10%. Because of this good number, our group recommend 4 steps. First is use job order costing. Second is buy the robotic welding machine. Third is make our control panel in-house. And lastly, use in the time inventory. If Innotech follow this step, this expansion will be huge success. I think that's all from us. Thank you.